Welcome back to the Deep Dive. Today we are strapping in for what might be the most intense exploration of the future we've ever attempted.
I think that's a fair description. It's
Yeah.
a big one.
Yeah. The sources we're looking at, I mean, they're not just predicting change. They're describing a change so rapid, it's basically a full civilizational shift.
Right. It's a deep dive into the coming age of abundance, the singularity, and all the, seismic cultural adjustments we'll need just to stay on the ride.
And the material really doesn't pull any punches, does it?
Yeah.
It offers these clear, sometimes pretty shocking timelines.
It does. And the core challenge they all seem to land on isn't can we build this future, but more. Can we integrate it without, breaking ourselves?
Right. How do we get the Star Trek future and not the Terminator future? That's the simplified question.
Exactly. And at the heart of it is what our sources are calling the supersonic tsunami, AI and robotics.
And the argument is that the singularity isn't something that's coming soon.
No, we're living in it right now. It's this period of accelerating, massive, simultaneous change.
Which promises immense prosperity.
But also, and this is the key part, immediate social disruption.
So our mission today is to really unpack that. We're going to zero in on the two biggest drivers behind this whole thing, AI and energy.
And we're going to focus on the really near-term timelines, like what happens in the next 3 to 7 years, because that's where the rubber meets the road.
Okay, so let's start with that tsunami wave, the immediate human impact. We have to talk about the job market.
Of course. And it's not what people have been expecting for the last few decades.
Not at all. The fear was always about manufacturing, right?
Yeah.
Robots on the assembly line. But our sources are pretty emphatic that white-collar labor is the immediate target.
Exactly. We're talking about anything involving digital information, tapping keys, moving a mouse, processing data.
My job, your job, a lot of our listeners' jobs.
It's the low-hanging fruit for AI. The models that exist right now can already perform, half or more of these knowledge worker tasks?
Right.
It's just so much easier to replace digital labor than physical labor.
So if huge parts of the information economy suddenly become automated in just a few years, what is that? What does that do to society? The material is brutally honest about this.
Yeah, it calls the transition bumpy, which I think is an understatement.
It leads to this paradox. Universal, high-income, A&D, social unrest.
That sounds like a total contradiction.
It feels like one, doesn't it? But it makes sense when you think about it in terms of identity, not just money.
What do you mean?
Well, one survey we looked at said 35% of Americans would rather live in the past. That isn't just nostalgia. It's anxiety. It's fear of losing your purpose, your agency.
And Hollywood has been feeding us the killer robot narrative for decades.
Right. So when you take away the necessity of work, especially for people whose whole identity is tied up in what they do, you create a vacuum. The unrest doesn't come from poverty. It comes from an existential crisis.
It's the Wall-E future, the challenge of avoiding it. The sources basically say humans have to get really, really good at creating their own challenges.
We have to shift from a struggle for survival to a struggle for meaning. Exactly. And that brings us right to AI safety. If we're going to design this future, what do we have to program into these systems from the start?
And the sources narrow it down to 3, sort of essential properties for a benign, Star Trek outcome.
I found this part fascinating. The first one is a commitment to truth. This is like the ultimate guardrail to prevent an AI from, as they put it, going insane.
Meaning it can't operate on false or contradictory information. It has to be grounded in reality.
Which links directly to the second property.
Yeah.
Curiosity. And AI has to find us. Interesting.
It has to value humanity. If its core programming includes a drive to understand novelty, and we are the biggest source of novelty on the planet.
Then it has a reason to keep us around. It's a symbiotic relationship.
And the third one?
A sense of beauty. This is to make sure the future it builds is a great future, not just an efficient one.
Because efficiency alone could be, pretty sterile. A perfectly optimized but miserable existence.
So you have truth, curiosity, and beauty. But are 3 values really enough to steer an intelligence that's about to surpass all of humanity combined?
That is the terrifying question, isn't it? Our laws, our social contracts, they have to adapt just as fast as the tech. And that feels like a much, much heavier lift.
And none of it matters if we don't solve the most foundational problem of all.
Energy.
Energy. If AI is the tsunami, energy is the ocean. The sources are so clear on this. Energy is the interlude for everything. The future currency is basically wattage.
And the scale is it's mind-boggling. The goal they lay out is for civilization to harness 1/1,000,000th of the sun's total energy output.
Which, to put that in context for you listening, is over 1,000 times the energy we can possibly produce on Earth right now.
And we're already hitting the wall. The limiting factor for AI compute in the next 2 years. It isn't chips. It's not silicon.
It's electricity generation and cooling, the boring stuff.
Transformers for transformers, as they say. The need to cool these massive data centers is maxing out local power grids.
There's this one case study that just blew my mind. The energy it takes to manufacture an entire car
Is less than the power needed by the data center just to train that car's AI to self-drive?
It's insane. And that demand is forcing this global gigawatt race.
You've basically got two very different strategies emerging. On one side, you have China.
They've done an incredible job on solar. I mean, the numbers are staggering. A production capacity of around 1,500 gigawatts a year.
And they added 500 terawatt hours in the last year alone. 70% of that was solar. They are just building capacity like crazy.
Meanwhile, the U.S. solution is different. It's more about optimization. It's about leveraging the grid we already have.
Right, through massive battery storage, things like megapacks. The U.S. peaks at about 1.1 terawatts of power use, but the average is only half that, around 0.5.
So the batteries just close that gap. You charge them at night when demand is low.
And discharge them during the day when everyone's using power. You can basically double your energy throughput without building a single new power plant.
It's a clever solution. But the prediction from the sources is pretty stark. They say China will pass 3 times the U.S. electricity output by 2026.
Which just shows you that the scale we need, we can't achieve it by staying on Earth. The gravity well is too deep.
So to get to that millionth of the sun's energy, you have to go to space. That's the real moonshot goal.
A path to creating 100 gigawatts a year of solar-powered AI satellites in orbit.
Which is a colossal engineering task. The sources estimate that to do this, we would need something like 10,000 Starship flights per year.
1,000,000 tons of payload to orbit every single year.
The only way that works, financially, is if you hit a tipping point on cost. The sources say you have to get the cost per kilogram well below $100.
Which all depends on a fully and rapidly reusable rocket. That's the key.
Once you break that barrier, the whole game changes. Asteroids become a source for raw materials.
A food source for manufacturing solar panels. You're building towards a Dyson swarm, conceptually. The cost of energy and materials just plummets towards zero.
And the engine behind all this, intelligence itself, is accelerating even faster.
Yeah.
We have to talk about these AI timelines. They are aggressive.
But very aggressive. AGI, artificial general intelligence, is predicted to hit next year, 2026.
And by 2030, the intelligence of AI systems will exceed the intelligence of all humans combined.
And what's wild is that the sources say even that prediction is seen as pessimistic by some people in the field.
How is that even possible?
Algorithmic improvements alone could boost intelligence density by like 2 orders of magnitude, 100 times better than what we have now.
Which brings up the big question.
Yeah.
Do we get one single super AI, a godlike mind that controls everything?
And the sources say no, the physics prevents it. The ultimate constraint is the speed of light.
Latency.
Latency. Because of the delay, you'll always have multiple AIs, competing, cooperating, evolving. There's a Darwinian pressure that prevents any single mind from taking over completely.
Okay, so we've got the infrastructure, abundant energy, abundant compute. Let's bring it back down to Earth. How does this change things that you, our listener, care about? Health and education.
Let's start with healthcare. The promise here is just incredible. They talk about humanoid robots like Optimus, and its usefulness isn't just one improvement.
It's a triple exponential function.
Exactly. The AI software, the chips, the physical dexterity, they're all improving at the same time and feeding into each other.
And the prediction is that Optimus will be a better surgeon than the best human surgeon in 3 years.
It sounds like science fiction, but the reasoning is the data loop. A human surgeon might do 1,000 operations in their lifetime.
An AI can simulate and learn from 1 million surgeries a day.
And so within 5 years, the best medical care, the kind that's currently reserved for billionaires, will be available to everyone globally for almost nothing.
Which makes longevity escape velocity a real possibility. The sources frame aging as a solvable problem.
Because the body is essentially programmed to die. So the goal is to extend human longevity to 120 or maybe 150 years to give us enough time for the AI-driven cures for aging to fully arrive.
The impact on health is staggering. And it's the same for education, which let's be honest, is fundamentally broken right now.
Completely. College attendance is way down. It was 75% in 2010. Now it's around 35%. The cost is insane. Tuition's up 900% since 1983.
And content is becoming irrelevant so quickly.
The fix is individualized AI teachers. Imagine a kid-friendly version of Grok that's an infinitely patient one-on-one tutor for every single student on Earth.
So what's the point of school then?
It becomes a social experience, a place for teamwork, connection, growing up. The actual learning can happen anywhere, anytime, with your personal AI.
Okay, so this all ties back to the idea of universal high income. But it's not about the government printing money.
No, crucially, it's not about taxation or redistribution. It's about massive deflation.
What does it mean exactly?
Think about it. When the cost of labor drops to near zero, and the cost of intelligence, design, knowledge, everything, also drops to near zero.
The price of everything crashes.
The price of everything essential crashes. Healthcare, education, housing, transport, all made by robots, powered by space solar, designed by AI. The result isn't universal high income, it's universal high stuff and services.
You just have what you need because it costs nothing to make.
Exactly. You make the need for cash irrelevant for basic survival and flourishing.
Well, this future is just. It's
That-
overwhelming. And the sources all stress that AI is moving maybe 10 times faster than government can even react.
Which means this isn't some force of nature, like a hurricane. It's a designed future. It's being actively steered by the handful of organizations building these systems.
And it's already pushing beyond what we can even understand. They expect that within a year, AI will be asking and solving problems that are incomprehensible to humans.
Right, like math questions that are pages long with solutions we can check are right, but that we could have never come up with on our own.
That acceleration, that strangeness, forces you to ask some really deep, almost metaphysical questions.
It really does.
So we want to leave you with a final provocative thought, something to just mull over. If you assume for a second that our reality is, say, an nth generation simulation, what's the Darwinian necessity that ensures our specific simulation keeps running?
The premise being that any creator would just shut down a simulation that gets boring, one that stops producing novelty.
So the fact that we are, right now, barreling headfirst into a future of guaranteed excitement, radical change, and constant novelty.
It might just be the thing that keeps the lights on. It might be proof we're in Act 3 of the greatest show in the universe.
Excitement guaranteed. We hope this deep dive gave you some tools to navigate this supersonic tsunami. Keep exploring this awesome, accelerating future.
And we'll be here next time to help you unpack your sources.